Standard large language models operate in a state of permanent amnesia. A user provides prompt details, the context window fills up, the model executes, and the moment the session ends, the container is emptied completely. Because of this, every new interaction starts from absolute zero. At the enterprise level, this stateless execution carries a severe operational cost. Organizations burn millions of tokens, waste expensive compute cycles, and endure massive latency penalties repeatedly feeding the exact same rules and context into the model. A system with no memory is simply a tool that responds. Enterprise workflows require an agent that learns. They require a system that explicitly recalls what worked yesterday and avoids the mistakes it made last week. Standard retrieval augmented generation cannot solve this. RAG injects static documents into a prompt, but it does not record the agent's own resulting actions or decisions. It creates a static reference library, not a cognitive feedback loop. Achieving true autonomous AI means abandoning text retrieval wrappers entirely. It requires engineering a dedicated operating system for cognition. Heartbeat Agents provides a persistent, structured memory vault functioning as a cognitive operating system. Anchored directly in PostgreSQL, it uses the PG vector extension instead of external databases. This entirely eliminates fragile sync pathways and external points of failure. Keeping everything inside a single database allows the system to execute native GIN full-text indexing alongside vector similarity search within a single, unified query. Furthermore, it guarantees a strict level of transactional consistency. Memory updates, creations, and deletions happen in the exact same transaction as other system state changes. Enterprise agentic memory must begin with this transactionally sound infrastructure. Eventual consistency bugs are fatal when an agent relies on immediate memory retrieval to execute its next autonomous action. Instead of dumping raw text into a single index, this OS categorizes data by function, mirroring human cognitive psychology. The system directs incoming data into 4 distinct memory streams. Semantic memory, the blue stream, holds the agent's absolute knowledge, the hard facts and preferences it must always know. Procedural memory, the emerald stream, stores the how. Complex multi-step workflows are recorded here as reusable recipes, reducing trial and error. Conversation memory, the purple stream, stores highly compressed summaries of past interactions, preserving continuity across long timelines without consuming excessive storage. Episodic memory, the amber stream, contains the agent's experiences. It logs specific tasks, attempts, and outcomes. The system applies a deliberate weighting asymmetry here. Successful outcomes receive an important score of 0.7. Failures receive a critical score of 0.9. By mathematically forcing the agent to prioritize negative boundaries, it learns exactly what not to do. This strictly prevents autonomous agents from repeating identical, expensive failure loops over and over, saving massive amounts of enterprise compute. To populate these 4 streams, the system requires redundant ingestion pathways. If an insight is generated, it must be captured. The first pathway is agent-initiated. During any execution, the AI can evaluate its own output and call a remember tool to actively store distilled insights. The second pathway is an automatic background extraction. Every 5 minutes, an independent LLM scans idle conversations, extracting high-signal facts, recording successful procedures, and noting user preferences. A cursor tracking mechanism marks exactly where the background model left off in each conversation. It exclusively scans new messages, strictly ensuring the AI never extracts duplicate memories from the exact same session. The third pathway is an invisible, automatic episodic recorder. After every single agent run, regardless of the prompt, the system transparently logs the exact outcome of the execution. Before any of this data hits the vault, it must pass a strict deduplication defense. The system runs a vector similarity check. Inputs exceeding strict cosine similarity thresholds are completely rejected. This rigorous thresholding is mandatory. Without it, redundant inputs create database bloat, poisoning the AI's logic baseline with noise. Retrieving this data is a precision exercise. By default, the system restricts memory injection to just 10% of the agent's maximum token context. Every retrieved token must count. Standard vector search converts queries into high-dimensional mathematics. It excels at finding semantic meaning, matching scheduling constraints with company holiday, but it routinely fails to recognize exact project acronyms or precise technical terminology. Conversely, PostgreSQL's native full-text search perfectly targets specific acronyms and exact database strings, but it completely ignores the underlying semantic intent of the user. This table illustrates the dual-signal composite ranking formula used to solve this. The system runs both searches simultaneously, covering their respective blind spots. Candidates are scored based on 55% vector match, 20% text match, 10% importance rating, and 15% recency. This graph plots exactly how that 15% recency weight functions. It uses an exponential decay curve. A 1-day-old memory receives a high multiplier, while a 30-day-old memory score drops to near zero. This naturally surfaces fresh information without deleting older records. But even with accurate scoring, the retrieval engine faces the operational threat of redundancy. A query about a deployment might return 12 memories that are highly relevant, but entirely identical to each other, completely wasting the token budget. To prevent this, the top 20 candidates are routed through a maximal marginal relevance algorithm. The system measures the word set overlap between the candidates using Jacquard similarity, iteratively selecting the 12 most mathematically distinct records. Because Jacquard similarity calculates overlap directly from the text arrays, this diversity filtering executes entirely within the system, requiring 0 additional API calls. This guarantees maximum information density. The agent receives a compact context payload, where every single token is unique, relevant, and mathematically justified. An infrastructural law dictates that a memory system that only accumulates data will inevitably degrade in performance. Quality must be actively maintained. The first automated maintenance pillar is consolidation. When multiple memories express the same concept in different ways, the system clusters them. Any group with a cosine similarity above 0.82 is merged by an LLM into a single, concise statement. This consolidation process executes continuously in the background every 6 hours for any agent whose vault exceeds 50 stored memories. The second pillar enforces a forgetting curve, formerly known as importance decay. Every 24 hours, a background task multiplies the importance score of every single memory by 0.995. Unused data is actively degraded. Once a memory score drops below 0.01, it is permanently deleted. The only way a memory survives is if the agent actively uses it. Retrieving a memory during a query reinforces its access count, pausing the decay and proving its operational value. The third pillar is a hard pruning tap. By default, an agent is restricted to 500 total memories. If it exceeds this threshold, the lowest importance records are systematically purged. Systematic algorithmic forgetting ensures the vector index remains lean. This is the exact mechanism required to guarantee sub-millisecond retrieval times at enterprise scale. Enterprise deployment carries a strict security mandate. Information cannot leak or cross-contaminate between different departmental AI models. To enforce this, every stored memory defaults to agent scope. The data is strictly isolated and mathematically invisible to any other agent on the network. An HR agent cannot surface insights generated by a marketing agent. However, organizations need a way to establish shared, universal truths, such as company-wide deployment targets or verified analytical workflows. This is handled through workspace scope. Administrators can explicitly promote a specific memory from an isolated agent scope up to the workspace scope. When an agent queries its memory, the system returns its private vault alongside this universal workspace knowledge. This explicit promotion mechanism ensures security while allowing a single agent's optimized discovery to instantly become organization-wide capability. An amnesiac LLM burns resources solving the exact same problems from scratch every day. A heartbeat agent captures the logic of a successful run once, ensuring subsequent attempts can build on that validated sequence rather than starting over. This architecture is built to outlast any single vendor. Different embedding models output vectors of varying lengths. To prevent database rebuilds when switching providers, all vectors are zero-padded to a uniform 1536 dimensions. The added zeros preserve the cosine angle, maintaining search accuracy across any underlying model. The system operates on a rigorous triad of managed cognition: store data intelligently by function, retrieve it using diverse mathematical signaling, and systematically forget the noise. This structure turns raw, ephemeral compute cycles into permanent, compounding institutional knowledge. Heartbeat Agents provides the persistent data layer required to move beyond basic generation, delivering the foundational operating system for autonomous enterprise AI.